Okay, today we're looking at topic 3, which is solving rational expressions. So these would, or that should really say equations. Let's fix that. Can't solve an expression, you have to solve an equation. Okay, so what does a rational equation look like? It would just be an equation with a bunch of fractions, a bunch of rational expressions. The steps here multiply each term by the LCD. So we're looking for the LCD for everything because we need all of them to have the same LCD, so every fraction in the problem. Then we solve the resulting equation that occurs in the numerator, okay? Check for extraneous solutions because you got to make sure that you don't divide by 0. Let's look at this first problem. 4 over x plus 3 plus 5 over 6 equals 23 over 18. Okay, so first we'll be looking for the GCD, or sorry, not the GCD, the LCD of all the fractions in the problem, which are x plus 3, 6, and 18. So let's factor all of those. X plus 3 is already factored. 6, that factors into 3 times 2. 18, that's 3 times 2 times 3. So the LCD here will be what they have in common. They all have well, they don't have anything in common. Well, these two have 3 and 2 in common. What they don't have in common is a 3 and an x plus 3. So the GCD here would be 18 x plus 3. Because two of them have a 3 and a 2 in common, and then they don't have a 3 in common, don't have an x plus 3 in common. So essentially that's 18 x plus times x plus 3. So we need to make all the denominators into 18x plus 3. So for the first one, we'd have to multiply by 18. The second one, we'd have to multiply by 3, x plus 3. So 3 and x plus 3. And the last one, we'd have to multiply by x plus 3. And that should make all of the denominators into 18 x plus 3. So 4 times 18, 72. So this becomes 72 over 18 x plus 3. 5 times 3 is 15. And 15 distributed into that becomes 15x plus 45 over 18x plus 3 equals 23 and x plus 3 that gets distributed, 23x plus 23 times 3, which is 69, over 18x plus 3. All right, so these can be written over the same denominator. So we have 72 plus 15x plus 45 over 18x plus 3 equals 23x plus 69 over 18x plus 3. And if you combine the like terms here, we have 15x and then 45 plus 72, 117. Over the LCD, I'm just going to write LCD, equals 23x plus 69 over the LCD. Now that both sides are over the same thing, they're over the same LCD, the numerators have to be equal. So we can just say 15x plus 117 equals 23x plus 69. And we can solve this equation. So I'll subtract 15x. Gives us 117 is equal to 23 minus 15, so that's 8x plus 69. Subtract 69. (48) equals 8x. Divide by 8. So x equals 6. So that would be our solution to this problem here. 4 over x plus 3 plus 5 over x equals 23 over 18. Our solution is 6. Now make sure that it doesn't cause any of the denominators to be 0. Okay, so it doesn't cause this denominator to be 0. These are not 0 anyways. So our solution is 6. And you can very easily check that, because if you plug that in, you get 4 over 9 plus 5 over 6 equals 23 over 18. And you can add these and see that they're 23 over 18, okay? Because you multiply this by 2, multiply this by 3. So you get 8 over 18 plus 15 over 18 equals 23 over 18, which is true. It's 23 over 18. Okay, so this is our solution, x is equal to 6. All right, number 2, we have 5 over y minus 2 plus 2 over 1 equals 17 over 6. Well, the LCD here would be the factors that they don't have in common. If they don't have anything, or that they do have in common, that none of them have anything in common. LCD is going to be 6, 1, and y minus 2. So 6 times y minus 2. To get that for the first problem, I would have to multiply by 6. Get that for the second problem, I would actually have to multiply by both 6 and y minus 2. To get that for the last fraction, I'd have to multiply by y minus 2. So I get 30 over the LCD plus, that's 2 times 6 is 12. 12 gets distributed, so 12y minus 24 over the LCD equals 17 gets distributed, 17y minus 34 over LCD. So combine these into a single fraction. So this is 30 plus 12y minus 24 over the LCD equals 17y minus 34 over the LCD. Now that they're both over the LCD, I can just set them, well actually let me combine these. 30 minus 24, that's 6. So this is 12y plus 6 over the LCD, 17y minus 34 over the LCD. Okay, now that they're both over the same thing, they're both over the LCD, I can just set the numerators equal to each other. 12y minus plus 6, 17y minus 34. And I can solve this equation. So I'll subtract 12y. So I get 6 is equal to 5y minus 34. Add 34 to both sides. 40 is equal to 5y. Divide by 5. Y is equal to 8. Check to make sure that doesn't cause any of the denominators to be 0 in the original problem. Y minus 2, that's fine. 1, 6, okay, so that's fine. So this is our solution. Y equals 8. And of course you can plug this in and check it. Number 3, we have 2 over x plus 1. Whoops. Minus 1 over x minus 1 equals negative 2 over x squared minus 1. So we need to check the LCD here. Okay, so this has factors x plus 1, this has factors x minus 1. This one, however, x squared minus 1, that needs to be factored because it's a difference of two squares. So it's x plus 1 minus 1 over x minus 1 equals negative 2 over x plus 1, x minus 1, because it's a difference of two squares. So the LCD is going to be what they have in common. They have an x plus 1 in common, and they have an x minus 1 in common. Okay, so x plus 1, x minus 1. To get that for the first one, we would have to multiply by x minus 1. For the second one, we'd have to multiply by x plus 1. And the second one has already got that as a denominator, so we're fine. So distribute here. So 2x minus 2 over the LCD minus, we don't really have to do anything there, x plus 1 over the LCD equals negative 2 over the LCD. All right, since this is subtraction, remember this, both of these get subtracted, so it's 2x minus 2 minus x minus 1 over the LCD equals negative 2 over the LCD. Combine the like terms, so 2x minus x is x, negative 2 minus 1 is negative 3, so x minus 3 over the LCD equals negative 2 over the LCD. Now that they're both over the LCD, I can just set the numerators equal. So x minus 3 equals negative 2. Add 3 to both sides. We get x equals 1 as our solution. However, there's a problem with this, because this solution causes this fraction to be undefined. It also causes this one to be undefined. So we actually have no solution, because the solution that we did find doesn't even work. So this one, no solution. And then number 4, 1 over p minus 2 equals 2p plus 1 over p squared plus 2p minus 8 plus 2 over p plus 4. All right, we need to make sure all the denominators are factored so that we can find our LCD. First one's fine, p minus 2. 2p plus 1, that's p squared plus 2p minus 8. That factors into p plus 4, p minus 2. And then plus 2 over p plus 4. All right, so the LCD, do they have anything in common? Well, yes, they both have a p plus 4 in common, and they have a p minus 2 in common. So the LCD is p plus 4, p minus 2. So to get that for the first fraction, I would need to multiply by p plus 4. To get that for the second fraction, well, it's already got that. And to get that for the last one, I would have to multiply by p minus 2. So this becomes p plus 4 over the LCD equals 2p plus 1 over the LCD plus, distribute, 2p minus 4 over the LCD. All right, combine these on the right side into a single fraction, so 2p plus 1 plus 2p minus 4 over the LCD. Combine the like terms on the right side, so 4p minus 3 over the LCD. Now that they're both over the same thing, the numerators have to be equal to each other. So p plus 4 equals 4p minus 3. Subtract p, and we get 4 is equal to 3p minus 3. Add 3. 7 is equal to 3p. Whoops. Divide by 3. And we get p is equal to 7 over 3. All right, that definitely works for all of the denominators because the only restricted values are -4 and 2. And I wasn't expecting to get a fraction, so let me make sure that I've got that solution correct here. Yeah, 7 over 3. All right, and that definitely works as a solution because it doesn't match my restricted values. So 7/3 is my solution to number 4. All right, here are the problems for the homework tonight.